Hello everyone, this is Swathi, working as Assistant Professor in the Department of Electronics and Communication Engineering in Institute of Aeronautical Engineering, Dundigal. Welcome to this lecture. In this lecture, we'll be discussing about what I mean by prime implicants, essential prime implicants, and how the reduction can be done or else simplification can be done by using Carnot map method, and also what are the don't care conditions and what is the importance of or else significance of don't care conditions in K-maps for simplifying the Boolean expressions. With examples we'll see. So first of all, we have seen a corner map. So we can have the corner map method is the graphical method of simplifying the Boolean function. Depending on the number of variables in the given function, we have to choose a particular K-map, and the number of cells in a K-map is equals to 2 power n, where n is the number of variables, n is the number of variables in the function, and each cell corresponds to 2 power any one of the 2 power n combinations of input variables. And once we have mapped the Boolean function with the K-map, the next step is to group the adjacent cells. And we already know that the two cells are said to be adjacent if they are differed by only 1 bit position. And the values of binary values to each and every cell are assigned using gray code instead of binary code. This is to make two neighboring cells as adjacent. If we use binary code, even though they are neighboring, they cannot become adjacent and we cannot group them together. So that is why instead of following the gray code, we will be following the order of binary representation in gray code order. So the combination of adjacent squares. So we have seen a 4 variable K-map. So the 4 variable K-map is having 16 cells. So these are the 16 cells, and the maximum possible group in a 4 variable K-map is a group of 16 cells. So group of 16 cells leads to the function which is equals to either 0 or 1. So that means the maximum possible group of a 4 variable K-map is 16. By forming a group of 16 cells, the function may become either 1 or 0. 1 or 0. The next possible group that we can form in a 4 variable K-map is octet, that is a group of 8 cells. By forming the group of 8 cells, we can have, or else each term can be represented with 3 literals or 3 variables. That means by forming the group of 8 cells, we can eliminate one variable. We can eliminate 3 variables, and we can have only 1 variable present in it. And similarly, the group of 4 cells, the next higher group is group of 4 cells, which is also known as quad. So by forming the quad, I can eliminate two variables, and hence each term after simplification will have only 2 variables which is resulted due to quad. And the group of 2 cells forms a variable with 3 literals, where we can eliminate 1 variable by forming a group of 2 cells. So this is a brief information about the 4 variable K-map. Okay, so other than 16, the group of 16 cells, we cannot form any other higher groups in a 4 variable K-map. So now, while choosing the adjacent squares in a map, we must ensure that all the minterms of the function are covered when we combine the squares. So whenever we are grouping, we have to ensure that all the minterms or maxterms have been covered by any one of the group. So if any minterm is not covered by any one of the group, then we should leave as it is. In that case, all the variables will be present in that prime implicant. Now the number of terms in the expression is minimized, and there are no redundant terms. Redundant terms means no repeated terms. So what we need to do whenever we are grouping the adjacent cells, the 2 things we need to keep in mind. What are that? We have to ensure that all the min terms or max terms have been covered by any one of the group, and we need to ensure that all the minterms or max terms have been covered by minimum number of groups, so that more simplified expression can be obtained. And one more thing that we have to remember, the number of terms in the expression is minimized. That means by forming the groups, we are able to minimize the number of terms, and there are no redundant terms. So that means if a minterm is covered by a group, then it is not necessary to use it another group. So such kind of grouping leads to redundancy. So we need to ensure that while grouping, there are no redundant terms in the simplified Boolean expression. So these are the things that we need to keep in mind whenever we are grouping the adjacent cells. Now let us see the prime implicants. What do you mean by prime implicant? What are the prime implicants? So the prime implicant is a product term, or we can also have a sum term. Product term or a sum term obtained by combining maximum possible number of adjacent squares in the K-map. So after grouping, we are going to write the product term or sum term. The product terms are written when we want to represent the Boolean function in SOP form. So we are going to write product terms if I want to get the Boolean expression in SOP. So, and we are going to write the sum term for the when we are representing the Boolean expression in the POS form. So after grouping, we will be writing either sum term or product term based on the form of expression we need. If we need sum of products form, then for the group we will be writing product term. If we need POS form, then we will be writing sum term. So if your minterm is once again the definition of prime implicant, it is a product term or sum term obtained by combining the maximum possible number of adjacent squares in the map. Adjacent squares or cells in the map is termed as prime implicant. Now coming to the essential prime implicant. Any prime implicant is said to be essential prime implicant if a minterm in a square covered only by one prime implicant. So prime implicant covers number of minterms, right? So if any one of the minterm is covered by only one group, then the prime implicant written for that particular group is known as essential, because this grouping must be present in order to cover that particular minterm, because that minterm is not at all covered by any other groups. So such type of prime implicants are said to be essential prime implicants. So if a minterm in a square is covered by only one prime implicant, that prime implicant is said to be essential. The prime implicant is essential if it is the only prime implicant that covers a minterm. If any one of the minterm is covered by only one group, then the prime implicant written for that particular group is said to be essential prime implicant. Now let us see the difference between essential prime implicants and prime implicants. How can we identify the essential prime implicants and prime implicants? Let us take an example and we'll try to analyze the difference between prime implicants and essential prime implicants. So consider the 4-variable Boolean function. This is given here. Some f of a, b, c, d, a, comma, b, comma, c, comma, d is equals to summation 0, 2, 3, 5, 7, 8, 9, 10, 11, 13, 15. So what is the form of this expression? This is given in the form of SOP, which is nothing but sum of product form. So whereas all these terms indicates the minterms, and this indicates the sum of products form representation. Now determine the essential prime implicants and the prime implicants. So this kind of question may be asked in your examination. So how to identify the essential prime implicants and prime implicants? So now first of all, let us map the Boolean function with the K-map. So how many variable Boolean function it is? It is a 4-variable Boolean expression. So for that, how many, what is the size of the K-map we require? We require a 4-variable K-map in which we have 16 cells. So this is a 4-variable K-map I'm taking here. So here the variables we have always should remember that we need to arrange them in the order given in the function. So ABCD 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0. So it is now this is 0 1 3 2 4 5 7 6 8 9 11 10 12 13 15 14. Okay, so this is a K map. Now I am going to map this Boolean expression with the K map here. So what is the meaning of this Boolean function? For all these min terms present in the expression, the function output is considered to be 1. Now mark all the respective cells of these min terms with 1 in the K map, because this expression is in the form of SOP. So 0. Okay, so I'm using another color in order to identify the difference. So 0, next is 2, this is 2, next 3, and then 5, next one is 5, this is 5, 7, 8, 9, and then 10, 11, 13, 15. So these are the, this is the mapping of Boolean expression. So now, whatever the thing that is given, first we need to identify, is there any essential groups or not, or else essential prime implicants or not. So as we already know that essential prime implicant is a prime implicant which can only cover a particular min term where it is not covered by any other groups. So now identify such kind of min terms which can covered by only one group. So here 0 is there. 0 there are no neighboring elements other than this corner elements. So I can form a group with these corner elements such that min term 0 is covered. So is there any other group that can cover M0? No, because we don't have any other neighboring elements to 0 other than these 4. So that is why I am grouping all these corner cells such that min term M0 is covered. So that is why what I can say that the group formed by this M0, M2, M1, M8 and M10 is an essential group, because this group only can cover the min term M0, whereas 0 cannot be covered by any other group. How I am saying that 0 cannot be covered by any other group? Because there are no other adjacent cells marked with 1 to the cell M0. So that is why this is the essential group. So this is an essential group. So in this K map, I am just marking only essential groups. So this is an essential group which can only cover the min term 0. Now similarly, observe 5 here. So I can use this 5 only in form. So whenever you are grouping, first you need to verify whether we can form the higher groups or not. Can I form a group of 16 cells here? No, because all the cells have not at all marked with 1. So I cannot form 16 cells, group of 16 cells. Can I form an octet here? Even we cannot find any 8 cells which are adjacent to each other. So that is why even I cannot form the octet. So what is the next higher group? Quad. That is a group of 4 cells. So now we have decided that the first possible highest group is quad, and after that we need to identify the essential groups which can only cover a particular min term. So like that we have identified this is a essential group where this only can cover the min term 0. Now let us see the 5. So min term 5, where min term 5 is also can be covered by only this group which is formed by the 4 cells M5, M7, M13 and M15. So any other groups are there for forming quads? So I can form a pair here, but it is a smaller group than the quad. So a quad can be formed such that min term 5 is covered. We have only one possibility, because we don't have one here. We don't have one here. So that is why only this is the possibility such that min term M5 is covered. So this is also said to be an essential group. So this is represented here. So these two are the essential groups. So now let us see 2. Can I use this 2 for forming any other group? Yes, I can form one more group with this 2 such that 2 is covered. So that is also a quad with these 2 and these 2. So that is why 2 is covered by other group also. And even 3. I can use this 2, 3, 11, 10. And also I can use this I can form this group such that this 3 is covered. That means there are 2 possibilities for 3 also. And now let us check 7. 7 is covered by this quad as well as this quad also. So that is why it is not essential. Whereas 13, 15, I can use this in this quad, or else I can also form a quad with this. Or else I can have a form a quad with these 4 such that 7, 15 is covered. Whereas 13 can be covered by more than one group, either by this group or by this group. And now coming to these 9 and 11. Let us see 9. 9 can be covered by this group and also this group. And 11 can be covered by this group or this group. So that is why other than 0 and 5, all the other minterms are covered by more than one groups. There is a possibility of covering all the other minterms by more than one group. So that is why only we have 2 essential prime implicants, and those are covering the minterms M0 and M5, where M0 and M5 cannot be covered by the other groups. So that is why these are said to be essential. Now let us write the prime implicant for these essential groups. So what is a prime implicant for this group? So it is a quad here, so which is occupying row 2 and 3 and column 2 and column 3. For row 2 and row 3, A value is varying. For row 2, A value is 0 and B value is 1. So A value is 1 for the row 3. So eliminate A. Whereas B value is common for row 2 and row 3. That means B value is common for all these 4 cells. So we need to consider B. As B is 1 and I want to get the expression in SOP. So take it in the true form. Now coming to the second and third column. So if I observe C value is 0 for second column and 1 for third column. So that means for these 2, C value is 0. For these 2 cells, C value is 1. That means C is varying. So eliminate C. Now look at the D value. D value is 1 for second column and 1 for third column. So that means all these 4 cells, D value is common, which is equals to 1, and hence take it in the true form. So this is the prime implicant or else essential prime implicant, which is a product term obtained by grouping M5, M7, M13, M15. That is BD. Now coming to the prime implicant of this group, so which is formed by the corner elements. So now corner elements means first row, last row. If you observe first row and last row, A value is varying, so eliminate A, whereas B value is common, which is equals to 0. So take it in the complement form. So B complement. And now this group is formed by first column and last column. So first column and last column, C value is varying, eliminate C, whereas D value is common, which is equals to 0, and take it also in complemented form. So that means BD, B complement, D complement are the essential prime implicants. Why we are calling this as essential prime implicant? Because these are prime implicants. Why? Because these groups only can cover M0 and M5, where the other groups cannot cover M0 and M5. That is why these are said to be essential. Essential means these are these are a part of simplified Boolean expression. That means simplified Boolean expression must consist of these 2 prime implicants. So now let us see what are all the minterms that are covered by these 2 groups other than M0 and M5. So M0 is covered, M2 is covered, M5 is covered, M7 is covered, next M13, next M15, and then M8 and M10. So these are all the minterms covered. Now let us see what are the minterms that are not covered by these 2 groups. Now we need to form the group such that the remaining minterms are covered. Okay, because in order to avoid the redundant terms. So now identify M0 is covered, 2 is covered, 5 is covered, and then 7 is covered. Next 13 is covered, 15 is covered, 8 is covered, 10 is covered. So only 9 and 11 are left. So 9 and 11 are left. So now I can form the group such that the remaining minterms 9 and 11 are covered here. So 9 and 3 is also not covered. 3, 9, 11 are not covered. So we need to form the group such that 3, 9 and 11 are covered with a minimum number of groups. Okay. So now let us see. Here this is forming a group with 3, 7, 15, 11 such that with this group 3, 11 are covered here and only 9 is left free. So 9 can be covered by this. So there is other possibilities also such that 11 is also covered. So with this group 11 is also covered, whereas we can also cover 3 by this group. Okay, so 11 and 9 are covered by this and this. So here that means I can use either this group or this group for covering the minterm M3. Similarly, I can use this group, that is group of all these 4 cells such that 9 and 11 are covered, or else I can also use this group such that 9 and 11 are covered, and even I left so I have 4 chances here. So that is 1, this is 2, whereas this one is 1 and this one is 1. So totally 4 possibilities are there. Are these 4 essential? No, either of these I can use. So now we observe that M5, M7, M13, M15 can be combined to get BD. M5 cannot be covered with any other squares, hence BD is the essential prime implicant. So M0, M2, M8, M10 can be combined to get B complement, D complement, where M0 cannot be combined with any other square and hence B complement, D complement is an essential prime implicant. So as we have, so I can form a group such that M3 is covered here. So what is the prime implicant for this one? Such that M3 is covered. So that is, so first row and last row, there where A value is varying, so eliminate A, B is common, so B complement, whereas C value is common for the third and fourth column, so take BD, whereas, C is common, which is equals to 1, whereas D is varying, eliminate D. So this is covering the minterm M3 and also M11. M3 and M3, M11 and M10. M10 is already covered by the group. So next, one more possibility is there. So I can also form a group with these so that I can cover what are the minterms that are covered here. M3 and M11 are covered. Okay, M3 and M11 are covered. So what is the prime implicant for this one? As A value, B value are varying, so eliminate A, B, whereas CD is common, so which is equals to 1 and hence CD. So these are the 2 possibilities such that M3 and M11 are covered. I can form any group. This is correct and this is also correct. So that is why I can choose any one of the group. So I have 2 possibilities here. Next, to cover 9 here, I can form a group with these 4. And what is the prime implicant for this one? A value is common for the third and fourth column. So consider A, whereas B is varying, eliminate B. Now second and third columns, C value is varying, eliminate C, D value is common, AD. So AD is a group which is covering M9, M11. Okay, now we have another possibility such that M9 is covered. So that is this group. So now what is the prime implicant for this one? So CD values are varying because we have 4 columns. So for all the 4 columns, CD values are not common. So eliminate CD. Whereas A value is 1, B value is 0. A value is 1, so A, and B value is 0, B complement. complement. So what is this covering? This is covering M9, M11. Okay, so these are the possibilities, different possibilities. That means I can take this and this, or else I can take this and this, or this and this. Like that, we have various options here. So now we can combine 13, 15, 9, 11 to get AD, M3, M2, M10, M11 to get B complement, to give B complement C. We can combine M3, M7, M15, M11 to give CD. This is what we have done. Okay, to give CD. Where we have got the CD, this one is CD. Next, we can combine M8, M9, 10, 11. So this one, this is the answer. M8, M9, M10, M11 to give AB complement. Where BD and B complement, D complement are essential. So I can use any of these two such that M3, M9, M9 and M11 are covered. So what are the remaining midterms that are not covered by these two essential prime implicants? Those are M3, M9, that is M3, M9 and M11. So that means I can consider this one. Okay. So as I told you that we have four possible options here, whereas BD plus B complement, D complement are essential of the simplified Boolean expression. I can use M9 and M11 such that they are covered by AD. And next, what is M9 and M11 are covered. Now I have to use either this or this. So I am using M3 here. So this one. So that is plus B complement C. This is one combination. So one more combination, BD plus B complement, D complement. So I am taking AD as it is. But I can also use this one where M3 is covered. So that is why I can also have CD. Or else I can have this BD plus B complement, D complement. Plus I can also take this one such that 9 and 11 are covered. So what is this one? AB complement plus I can use either B complement C. Okay, I can use either B complement C for covering M3, or else I can also use the CD here, BD plus B complement, D complement plus AB complement plus CD. Okay, so these are the four possible answers of simplified Boolean expression. So in order to avoid the redundancy. So this is about, so these are the essential prime implicants, EPI, whereas these are the prime implicants. Prime implicants means we can have another options also. I can use this or this or this, whereas this must and should present in the simplified expression. So that is why it is called as essential prime implicants. So this we have four possible answers here. So therefore, we have the following combinations: BD plus B complement, D complement, AD plus B complement C, or CD, AB complement CD, AB complement B complement C. So this is a major drawback of Karnaugh map. That is, I cannot have a unique answer. I cannot have a unique answer. Someone may group this one, or someone may get this, someone may get this, someone may get this answer. So we cannot have the unique simplified Boolean expression with the K-map. That is a drawback that we can now identify. Even though it is simple, but sometimes the answer may not be unique because we have various options for grouping while grouping. Okay. So this is about how to find the prime implicants and essential prime implicants. I think it is clear. Now let us see don't care conditions. What is the significance of don't care conditions in simplifying the Boolean function? So first of all, what do you mean by don't care conditions? So in some applications, the function is not specified for certain combinations of input variables. So we have, for example, BCD code. What is a BCD code? It is also a 8421 code where we can have 16 combinations, but I am going to use only 10 out of 16. So only 10 combinations are used. Those are from 0002 to 1001. Whereas the remaining combination 1010 to 1111 are unspecified. So these are unused combinations in BCD. Why only 10? Because we are only coding the decimal digits. How many decimal digits we have? 10. So that is why I need only 10 codes. That means in order to code the decimal digits into binary, I require only 10 combinations. Whereas the remaining 6 combinations are unused, or else we can also call it as unspecified combinations. This is the example. So as I told you that some of the applications, the function is not specified. Not specified in the sense the output of the function for some of the combinations neither 0 nor 1. So we cannot specify the output. Such type of combinations are called as don't care conditions. Okay, and the functions that have unspecified outputs for the sum of the input combinations are called as incompletely specified functions. Okay, whatever the functions that have unspecified outputs for some of the input combinations, such type of functions are called as incompletely specified functions. If it is having all the specified, that means if the output we can specify for all the possible input combination, then such type of function is said to be completely specified Boolean expression. So in most of the applications, we simply don't care what value is assumed by the function for unspecified minterms. So for some cases, we will not be concentrating on don't care conditions for which the output is unspecified. Okay, the unspecified minterms of a function are don't care conditions. So whatever the unspecified conditions we have for a function, those are said to be don't care conditions. So the don't care conditions can be used on a map to provide further simplification of the expression. So if any function is having don't care combinations, we can also use them in a K-map for forming the higher groups such that more simplified expression can be obtained. Why I can use this? Because it is unspecified. I can consider it as either 0 or 1. So that is why such type of unspecified combinations can also be used in simplification such that more simplified expression can be obtained. So the don't care combination, the don't care minterm is a combination of variables whose logical value is not specified. To distinguish the don't care conditions from ones and zeros, we always use X. So wherever we come across X, it indicates that it is a don't care condition. That means the function output is not specified for that particular combinations. So don't care conditions are represented with X. So X inside a square in the map indicates that we don't care whether the value is 0 or 1 is assigned to F for the particular minterm. So that means whatever it may be the value of that or a function for that particular combination, either it is 0 or 1. We are not bothered about it, but I can use this don't care condition while grouping to get the more simplified expression. So in choosing adjacent square, to simplify the function in a map, the don't care minterms may be assumed to be either 0 or 1. So if any don't care conditions are present, so we can consider it as either 0 or 1 while grouping. So whenever you are grouping zeros, don't care condition can be considered as 0. If you are grouping ones, then you can consider the don't care conditions as 1 because it is not specified. But one thing, so if it is required, you can use the don't care conditions to get the more simplified expression, but it is not mandatory to cover all the don't care condition. Only we need to check whether the ones and zeros are covered. If it is required, you can use the don't care so that the minimized expression can be, that means so that the higher groups are formed and hence the minimized expression can be obtained. But it is not mandatory that to cover all the don't care conditions while grouping. So this thing we have to remember. So the remaining all the thing is same. Now we have an example. So let us see how to simplify a Boolean expression which is having don't care conditions. So f of w x comma y comma z is equals to 1, 3, 7, 11, 15 summation 0 to 5. So here don't care conditions are represented with D, whereas they are mapped in the K map with X. So this indicates that these are the don't care condition. Means what? For these combinations or else for these minterms, the output of the function is not specified. So these are don't care. 0, 2, 5 or the don't care. Now I'm going to map this. So here I'm drawing the K-map again so you can understand easily. So here now I'm drawing the K-map. So how many variable function it is? It is a 4 variable function and the variables are w, x, y, z. So I'm writing them w, x, y, z, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Right? So now, how can I map this? First, map the minterms for which the function output is considered to be 1 because it is given in SOP form. So for all these respective minterms, place 1 in the K-map. So it is 1, next 3, next 7. 7 is, where is 7 here? And 11, 8, 9, 11, 10. So this is 11 and 15. 15 is this one, right? This is 0, 1, 3, 2, next 4, 5, 7, 6, 8, 9, 10, 11, 10, 12, 13, 15, 14, right? So this is the K-map mapping. Once the mapping of SOP is done, go for the don't cares. So for all these minterms, place X. So 0, don't care, and 2, don't care, and 5 is also don't care. So now here, if you look at the ones, so what we can do, I can group only these two pair, whereas I can form a quad with these. Okay, I can form a quad with these 4 because these are all adjacent to each other, whereas this one is left. So I need to form another group such that this one is also covered. So I can have, as I told you that whenever it is needed, I can use a don't care. So I can form a group with these 4. So with these 4, I can cover this one. Is this group required? Not required because all the ones have been covered. As I told you that it is not mandatory to cover all the don't cares. If it is needed to form groups, higher groups, you can use a don't care, but it is not mandatory to cover all the don't care. So even though I can form a group with this, but it is not needed because all the ones have been covered by these 2 groups only. So that is, what is the prime implicant for this one? So the prime implicant is wx values are varying, eliminate wx, where yz values are equal to 1, so yz. Now coming to this one, what is the prime implicant? W value is common, which is equals to 0, so w complement, where x value is varying, eliminate x, and y value is varying again, eliminate y, z value is common, wz. So that is f is equals to w complement z plus yz. This is the simplified expression. If I would not consider this don't care, so I could have form a pair with this. So if I form a pair, so how many variables I can eliminate? I can eliminate only one variable. But by considering the don't care, I could form a quad so that I could eliminate 2 variables and hence I could get the more simplified expression. So there is another possibility. So I can also form a quad with this 4 such that this one is covered. Not only forming a quad, this quad also covers the 1. So that is why we can have again 2 answers here. So this one is yz and this one is nothing but w complement x complement. We have again 2 possible outputs. One is w complement x complement plus yz, whereas w complement z plus yz. So this is don't care conditions. So the thing you have to remember is, if it is needed, we can use the don't care conditions in grouping. If it is not mandatory to cover all the don't cares. So that is the one of the problem. So now simplify the following Boolean function. So one more, simplify the following Boolean function. So one thing, here I have this expression, right? So we have totally how many variable function it is? 4. Totally 16 combinations we have. So for some of the combinations, the output is specified as 1, and for 3 of the combinations are considered to be don't care. And what about the rest of the other remaining terms? We have to consider that the function output is equals to 0 for the remaining all the min terms which are not present in these both. So that is marked here. So 0, 1, 2, 3 are marked here. 4 is 0. Okay. M4 is 0. Next, M5 we are already there. M6 is 0. Next, M7 is there. 8, 9, 0, 0. And 10 is also 0. 12, 13. Okay, 14 is 0. So this is, okay. So this is the Boolean function. Now, simplify a Boolean function which is given as A complement, B complement, C complement plus B complement, CD complement plus A complement, B, CD complement plus AB complement, C complement. Now, I want to simplify this one. So, can I map the Boolean expression directly with the K-map? No, because it is not in a canonical form. It is just a standard form of Boolean expression. So now what we need to do, we need to convert this into canonical form. This is SOP, right? Sum of products. How can I convert a sum of products form into canonical form? Just multiply with a term formed by the missing variable and its complement. That is one method. So if I could convert that into standard form, so what I can get as a variable missing is D here, because it is a 4 variable function. So A complement, B complement, C complement, D plus D complement plus B complement, C D complement, A plus A complement, because the missing variable is A, plus the third term does not have any missing variables, A complement, B, C, D complement plus A, B complement, C complement, D plus D complement. So now I can write this one as A complement, B complement, C complement, D plus A complement, B complement, C complement, D complement plus A, B complement, C, D complement. Okay, plus A complement, B complement, C, D complement. Next, plus A complement, B, C, D complement. Next, plus A complement, B complement, A plus B complement, C complement plus into D, A, B complement, C complement, D complement. Now, we need to identify the redundant terms, repeated terms if any we have, we need to eliminate them. Do we have any redundant terms? So, this is not common, A complement, B complement, C complement, D plus, whereas this is also not common, A complement, B complement, C complement, D complement, AB complement, CD complement, AB complement, CD complement plus A complement, B complement, CD complement plus A complement, B, CD complement plus AB complement, C complement, D plus AB complement, C complement, D complement. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this is the answer here. So this is how can I write this one. So that is how you can write the function, or else you can also write it as. So now I can write this one. A complement, B complement, this is M1 and this one is M0 and this one is 1, 0, 1, 0, that is M10 and this one is M2 and this one is 0, 1, 1, 0. This is M6 and this one is 1, 0, 0, 1, M9 and this one is M8. M8. So that means I can write this function as summation M of 1, 0, 10, 2, 10, 2 and this one is 6, 9, 8. If I rearrange the terms, F is equals to summation M of 0, 1, 2, 6, 8, 9, 10. 6, 8, 9, 10. So like this you can map. So M0, M1, M2, M6, M8, M9, M10. Or else we can also convert a given expression into standard form, canonical form by this way. First take the first term. What is the binary equivalent of this one? 0, 0, 0, where D is missing. So the D value can be either 0 or 1. So I can write this one as 0, 0, 0, 0 plus 0, 0, 0, 0, 1. So that is M0, M1. Next, take the second term. Which one is missing? A is missing. A value may be either 0 or 1. So, whereas B value is 0, 1, 0. So, 0, 0, 1, 0, 1, 0, 1, 0. So, 0, 0, 1, 0 is M2 and 1, 0, 1, 0 is M10. Okay. Next, fourth term as it is we have, that is fourth term is AB complement C complement. So A value is 1, 0, 0, where D value is missing. So D value may be either 0 or 1. If I consider 0, 1, 0, 0, 0, 1, 0, 0, 1. So that is M8, M9. And third term is all having all the variables. So that is 0, 1, 1, 0. That is M6. So now this way also we can form the groups. So first one M0, M1. Next M2, M10. And then M8, M9, and finally M6. Now form the groups here. So now we can form the groups. So first of all, by looking at this one, we can form a quad with this 4. So can I form any octets here? No, I cannot form any octets. So now this one is left here. This one is left here free. So I can form one more quad with these corner elements. With these corner elements. Now all these ones are covered other than this one. So this one is having only one adjacent cell. So I can form a group with these two such that a pair is formed. So as I told you that how many variable function it is? It is a 4 variable function. So as it is a 4 variable function, if I could form a quad, so how many variables I can eliminate? I can eliminate 2 variables. So what is the Boolean what is the prime implicant for this one? First row, last row, A value is varying, eliminate A, B value is common, so B complement. First column and second column, C value is common, D value is varying, eliminate. C value is 0, B complement, C complement. Now coming to the quad of corner elements, first row, last row, A value is varying, eliminate, B value is common, so B complement. And now first column and last column, so C value is varying, eliminate C, D value is common, which is D is equals to 0, D complement. Now coming to this one, so as it is a pair, I can eliminate only one variable, so hence I can have 3 variable term here. So first row and second row, A value is common, so which is equals to 0, A complement. And only it is occupying, this group is formed in the fourth column, where for the fourth column, C value is 1 and D value is 0. So C, D complement. So finally the simplified expression is A complement C, D complement plus B complement C complement plus B complement D complement. So this is the simplified expression. Now one more thing. So that is how we can simplify the Boolean expression. Now we can have one more thing that is to remember, to obtain the complement of the function. So how can we get the complement of a Boolean expression using K-map? So first, if the function is given in SOP form, then mark the empty squares with 0 and group all the zeros and write down the sum of products form for the given expression, which is nothing but F complement. So this is also SOP. Now I want to get the POS. What is the POS? The complement of complement will give you F, which is again in POS form. So that is the procedure. Now the problem is given. Simplify the following Boolean function into sum of products form and product of sums form. So now coming to the solution here. So first of all, I'm going to map this. So first I want to get the simplified Boolean expression in sum of products form. Okay, and here it is given, or else I will do it. So A, B, C, D, 0, 0, 0 1 1 1 1 0 0 0 0 1 1 1 1 0. Now, so this is SOP, means these are all the minterms for which the function output is considered to be 1. 1, okay, this is 1. Next, 1, 0, 1. Next 2, this is 2. Next 5, 8, 9, 10. 8, 9, 10. So this is the mapping here. Now group them together. So now I can form a group with these 4 so that a quad is formed. And one more, I can form a group with this corner element so that one more quad is formed. And 1, 1 is left here. So I could not form any other groups. I can use this one again such that 1 is covered here. Okay, so even though these 2 ones are covered by this group, but I am using them again such that one more quad is formed in order to get the more simplified expression. Now, what is the Boolean function here? So first, for the corner elements, the K-map is first row, last row. So A value is varying, eliminate A, B value is common, so B complement. And first row, first column and last column, C value is varying, eliminate C, D value is common, D complement. Next, this quad. So now I am writing the prime implicant for this quad. Again, first row and last row, so B complement. First column and second column, C is common, D is varying, B is complement, C complement. Now coming to this one, so A value is common, so A complement, where B value is varying, eliminate, C, D or C common, C complement, D. So the sum of products form of simplified Boolean expression is B complement D complement plus B complement C complement plus A complement C complement D. So this is the sum of products form. Okay, so now to get the product of sums form. So what I want to do, I want to identify what are all the minterms that are not present in this one. So now I am writing this A, B, C, D. So pi of, so what are all the terms that are not present in this one? 0, 1, 2 is there, 3, 4, 6, 7, 8, 9, 10 are there, 11, 12, 13, 14, 15. Now mark all the cells with that. So here 3, 4, 6, 7, 11, 12, 13, 14, 15. So 3, 4, 6, 7, 11, 12, 13, 15, 14. Now group only zeros. Now form the groups of zeros. So now form the groups of zeros. So how can I form the groups here? I can form a quad with these 4. Okay, because these 2 are adjacent, these 2 are adjacent, these 2 are adjacent. And again these 2. So all these 4 are adjacent to each other. So zeros are covered. Now I can form one more quad with this. So I can cover all these 4 cells. Okay. So next I can also form one more. So because this 0 is left, I have formed 2 quads here, but this 0 is left. So I can also use this quad. So now I'm writing the prime implicants for this one. So for this quad, the prime implicant can be, so as A value is varying, eliminate A, B. So B is common and equal to 1. Now coming to the first and last columns. So here C value is varying, eliminate C. D value is common, BD complement. Okay, BD complement. And then coming to this one, so AB values are varying, eliminate AB, and CD values are common, that is CD. Now coming to this one, so CD values are varying for all these 4 cells, AB values are common. So that is AB, CD plus BD complement. So this is nothing but F complement, because I am grouping zeros, but I am not writing the sum terms, I am writing the product terms itself. So which indicates the complement of the Boolean function. Okay, now once it is done, now I want to get the expression in POS form. So if I take the complement of this complement, then it will give you the sum of products form. Sorry, product of sums form. So I'm taking the complement of this one. So that is AB plus CD plus BD complement whole complement, which is F complement whole complement, which is equals to F in POS form. F in POS form. So I can write it as A complement plus B complement. This plus will change to dot, and C complement plus D complement. Again plus will change to dot, B complement plus D. So this is the answer. Or else we can also do this one in another way. What is the other way here? So we need to get the same expression, right? So what I'm doing, I'm just mapping, I'm taking a K-map, 4 variable K-map. Directly I can do it, or else first find out the complement and take its complement again. That will also give you the Boolean function in PYS 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Now we have already written the expression of PYS. So just map all these. 3, next 4, 6, 7, next 11, 12, 13, 14, 15. So this is there, right? So now I can form the groups of adjacent cells here. So I can form the group with this, and again I can form the group with this, and I can form the group with this. Instead of writing product terms, write the sum terms here. So what is a sum term? Directly I can get F. So what is a sum term for this one? As CD values are varying, eliminate CD, whereas AB values are common, which are equals to 1, 1. So I can take it as A complement plus B complement. Okay, this is A complement plus B complement. Now for this one, AB values are varying, eliminate AB, whereas CD values are common, which are equals to 1, and I'm writing the sum term. So and hence take the variables in complement form. Now for this one, so A value is varying, eliminate, B value is common, which is equals to 1, B complement, plus C value is varying here from this one to this, eliminate C, D value is common, which is equals to 0, take it in the true form. Now finally the function is given by A complement plus B complement into, after getting the sum terms, just multiply them together or else product them together. C complement plus D complement into B complement plus D. So this is the PYS form. This is the PYS form. Or else another way also we can do it. So we all know that the dual of SOP is nothing but PYS. Dual of SOP is nothing but PYS. So this is the expression here. So we can also get the dual of SOP as PYS. That is how we can do that, and we can simplify the Boolean expression. So we can either form the complement by grouping all the zeros and writing the product terms, and after getting the complement, take again the complement of F complement, so that it will give you the Boolean function in PYS form. So if you observe A complement plus B complement, A complement plus B complement, C complement plus D complement, C complement plus D complement, B complement plus D. So either of the way you do it, the answer will be same. Okay, so this is about the K maps, don't care conditions, its significance, significance of don't care conditions in K map simplification, that is the simplification of Boolean expression. And we have seen how to get a Boolean function in the form of SOP as well as in the form of PYS using K-map we have seen. So I hope it is clear to you all. That's all for this lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.